Hello, folks. This is David D. Hilser, critical thinker, dissident scientist. And if you are not science woke, then this is a place for you. There are literally thousands and thousands of scientists from around the world who have been working for decades outside the mainstream, who have identified problems, fixed those problems, and who are proposing new theories and models. You won't find anything like this on YouTube, so make sure you go down below and click on that subscribe button right down below and the little bell next to it, and you'll be alerted to when our next video drops. Hallelujah. You're not going to believe it. Today, I'm not going to be talking myself. I'm David D. Hilser, dissident science host, and I have none other than one of the top recommended, if probably not the top recommended book and author. And here he is, Alexander Unsker from Germany. Hello, Alexander.
Hi, David. Hi.
People on my channel, I've been threatening to talk to you for months, and it's either you or me. And
So hello to everybody. Yeah.
yeah, finally here. And yeah, I'm even thinking, I think sometime in the future for us maybe to even do a live session and have people answer questions. And that's always fun because then you never know what you'll get. But thank you so much. And I'm going to hopefully do a couple interviews with you. So this is going to be the first one today. And you just came out with, recently, you came out with a new book. I'm showing that right now to the audience. Whoops, no, that's the wrong one. I've got it in front of me. Yeah, he's famous for his Higgs fake and bankrupting physics, but his latest, Einstein's Lost Key, is quite a read. I just went through it again today. I had read through it a couple times, and we're going to talk about this book. So my first question to you, Alexander, is how did you get into the idea for this book, Einstein's Lost Key? Where did this come from? Because the other book, the Higgs fake comes along from. You can sort of read it. Oh, the Higgs particle. You've have criticisms of that, and bankrupting physics is sort of a logical. It's together with that kind of book. But the Einstein Lost Key is a little different. It's a departure, really, for you. Well, how did that start for you?
Well, I mean, that's a consequence of my entire study of physics and the history of physics. And when I started writing books, I mean, I was always interested in cosmology and astronomy, and while you're doing research, you're always deeping digger. So I discovered a couple of very interesting things, but well, it was not yet the time to write a book about. So I had first these other books about the general state of physics, and as you said, these first books were very critical about the current state of affairs. And maybe I don't think I don't think I'm in first place the guy who wants to be provocative about physics, who wants to annoy other physicists and to criticize them. That's not my really interest, at the very end. I consider myself as a researcher, and I think there are lots of interesting questions which are not solved to this day. But of course, I mean, if you enter the game, if you want to argue, if you want to discuss, you face all this nonsense. So I mean, you have to argue in a structured way why this and that, why you're not following that kind of particular fashion. And so that's a little bit why the motivation for my first books. But at a certain point, so to speak, I want to come back and to real physics and to be constructive and also, I mean, meet a little bit my critics who said that, well, this guy is only criticizing. Yeah, he hasn't done anything real, anything constructive. But I think, well, you have to argue. You have to put things in the proper order, and it is certainly, I think, the content of Einstein's Lost Key is more important, I think, yeah, than the critique of particle physics in a way. And my own state of mind also in the last years, if I look back when I started writing books about physics, being an author, it's almost 10 years ago. When I started to to write about string theory, to criticize this and that. I got really annoyed back then about, and you get in a state of emotion, and you feel the need to say something about these other absurdities, about this widespread foolishness in contemporary physics. But at a certain point, you can't spend your life just ridiculing all the nonsense which is put out by physicists every day. I mean, I write in my there is one phrase in my diary among various thoughts I try to remember every day, and don't fight the shit. I mean, don't spend your entire life about with criticizing, and instead focus on the really questions, on the deep unsolved problems, and that's where I wanted to go.
Yeah, I mean, I think that's one of the things about my channel, is I always say that one of the things I get compliments on the channel is it's really easy for me to go through the how do you say, I do that once in a while. I'll get an article, and I try to show people how to read the nonsense that comes out of mainstream media about physics. And you have 11 dimensions, multiverses, and history eraser, those kinds of things. And one of the things that people say, he says, Dave, there's a lot of people who criticize a lot of things, but what I like about your channel is you provide other people's ideas, new ideas. What are some of the people outside thinking? And and right now, I believe we're really in a model revolution, and that is, we don't know what the answer is, so we're going to have a lot of different ideas competing right now, and it's an exciting time. And like you said, I was really surprised. I go, wait a minute. Alexander Unsker is like writing a book about like doing physics. I was a little shocked too, in a good way. And I remember one thing you said to us, and when we had a interview with you a couple times at our conference, and you said something really profound. And I think people are wanting, they're always wanting you, Alexander, can you bless my idea or my theory or my model? And you basically said something that was really took me a year to really grasp, which I really understand now, is because we're in model revolution according to Kuhn's own description, and that is work on your stuff. Everybody work on it. And I think the problem is, of course, as you and I know very well, is that problem is when people say, well, you don't have a PhD in physics, and I have a great answer for them. Well, I can't get one. You know why? Because what I would want to write, you wouldn't give it to me. And so anyways, I think that's really great. So let's get into a little bit of the meat.
Yeah, let me just add something.
Okay. Sure.
I really think it's great what you're doing, this initiative, and there is definitely a need to set up something against the mainstream of science, because it's so, I mean, everybody rehashes the same opinion. There's a lot of parroting in mainstream science, and what we need is an alternative, and you're providing this platform. And well, there's just one caveat, I mean, we're not the same state of mind, in the sense that we the heterodox thinkers have a common opinion, like the mainstream has a common opinion, because it's at the very basic of science that you need more diversity, and of course, if we talk with others, it also often happens that we disagree about something.
Sure.
Because once you stop parroting, once you start thinking by yourself, you necessarily disagree with others, or more easily disagree with others. So we shouldn't be discouraged of the fact that we, if I may say that we alternatives are not necessarily of the same opinion all the time, but it's definitely, if there is a revolution in physics, I don't know if there is one, but definitely not created by the mainstream. If there is a revolution, there will be one lonely smart genius who revolutionizes physics, and that's the way of thinking, the way of working we must encourage. And I think what you're doing is really a good contribution, a valuable contribution to that.
Oh, well, thank you very much. Thank you. I think we're going to be launching our Science Woke website, and I was putting it together, and believe it or not, it was only about a week ago after having this and having you as one of our on our editorial staff. Hopefully, I'll get you to write something for us, maybe once a month. But the idea was, I was thinking, wait a minute, this is a science magazine for critical thinkers. That's what this is, and there's just nothing out there like that. So I really appreciate it, and having you here. I mean, like I said, you're in this arena of people who are outside the mainstream and really trying to look at things. You've got quite a name for yourselves, despite what you keep saying you're not famous, but in our circles you are. But let me get to back to your book here, and this is really quite fascinating because here you are, a German from Germany, of course, and Einstein is often looked upon as a god, often I think for the wrong reasons. But you have in your first chapter and in Einstein's Lost Key, we got a couple of things going on there. First of all, Lost Key means you have discovered something. And that's what this book is about. And you, in the first chapter, it says why Einstein's best idea remains unknown to this day. So tell the audience what you found. I mean, this is quite. I know, but I'm not going to give it away.
Yeah, it's difficult to start. Where to start? Well, I mean, if you look at Einstein's work, everybody believes that it's well known and it's well studied, but in reality, people focus on a very, very tiny part of Einstein's papers and works, which is special relativity in 1905 and general relativity in the final form of 1915. But there is these 10 years in between. We're just, well, what did he do? I don't know. It's incredible, but these were 10 years of intense thinking, pondering, working about the foundations of general relativity. And I believe that the best version of general relativity Einstein already found in 1907 or 1911. And that's the real great idea, his very first idea of general relativity. And that's a theory of with variable speed of light. And that's why I called the book Einstein's Lost Key. I think that's Einstein's most important contribution to physics, and well, it showed up, so to speak, at the very end in a wrong dress. I mean, he discovered something very profound of nature of gravity, but this mathematical fashion in which the theory was expressed in 1915, that's not the last word. That's what I want to say. And well, of course, people are skeptical, and you're not buying immediately all these claims. But what I want to say is just look at the history, look at these papers, and look also how nicely they fit into other people's ideas.
No, I mean it was really fantastic. When I was reading through it, even again this morning, I was thinking to myself, okay, variable. I mean, first of all, the whole idea that Einstein would talk about a variable speed of light is totally foreign. But one of the things is when my mom, God rest her soul, was in my movie called Einstein Wrong, I asked her after going on a journey, and I took an average person, my mom, and put them out there with all these critical thinkers who were thinking different ideas. And I said, now that you've gone through many years and know all these people, and you hear a lot about Einstein. In fact, we interviewed Einstein's friend, Jack Rosenberg, in 2006. He was 87 at the time. And I said, well, what do you think, Mom? And this is just a regular person out there. Do you think Einstein would be upset about if people were to debate his theories or to question things, or for to say, hey, Einstein, you said this, but I'm not buying it. Maybe there's when you talk about the variable speed of light,
he would ridicule the gullibility of people who are just buying his theories and making a religion out of it. I think he would be amused more than anything. else.
Well,
But I interrupted you. Yeah.
no, 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 exactly. That's what I was going to ask you is because I know when I talk with Jack Rosenthal, I think is his name. He literally went to Einstein's home in Princeton for the last couple years of his life, of Einstein's life, and one of the things he noticed that Einstein was in fact amused. He was amused by his own fame, didn't always understand it, but he also took advantage of it when he would go to physics lectures because so many people hated and loved him at the same time. They also hated him because of his own fame, but it wasn't his problem. I mean, he wasn't really one, I don't think, that was out there, pushing his fame like some, evangelists saying, I am great, and going out there and he was. So what was it that you felt? Because in our community, saying that light's variable speed, well, this is cool to us. It's cool to me. It's another perspective, and I got to go. Wait a minute. Hey, this is a new. What was your feeling when you were going to bring this out? Because one of the most important aspects of Einstein's work is the constancy of C. Because without it, then what happens to even special relativity? So tell me how you address that. I mean, because that's really if you were to say anything about this book, it's the variable lattice C. And how does that, with this conflict of the perception of Einstein and with Einstein's real thoughts about that, they seem to be different, aren't they?
Yeah. Well, I try to be short about my motivation, which is it's not only Einstein's idea, but it's the relation his idea had with so many other profound thinkers, like Robert Dicke in 1957, like Dennis Sciama in 1953, like Erwin Schrödinger, even Erwin Schrödinger in 1925, and of course Ernst Mach, and maybe first of all Paul Dirac with his cosmology. And right. I just, by studying all these old papers, I said, wow, that's incredible. And these guys, they didn't talk to each other. I was terrified. It was so sad to see these very same ideas written down by these geniuses, and they just didn't talk about this stuff, I mean, and I think it's just a matter of putting things together, these various puzzles, and that's the basic motivation. Yeah, I said you have to bring this out. You have to tell that there is a relation between Dirac and Einstein. You have to tell the world that they didn't talk. You have to just to present these old papers and let people draw their own conclusions. That's the basic motivation. Yeah. And
wow, that's great. Yeah, that's great. Mm-hmm. So I'm going to go on here because I know that, I could sit here actually for about 30 hours, but let's go forward. Yeah. I'm going to skip it. Go ahead.
If I might add something.
Sure.
Well, regarding Einstein, then there is something I admire about content, so to speak. I think it's a really good idea, that variable speed of light. But let's also consider not only the content, but also the method, And what I really appreciate, I mean, he published a lot of theories, and he was often contradicting himself. So obviously not everything is right what he wrote. Okay, sure. We know that.
Sure.
But he was a honest, dedicated scientist really in search of the truth, so to speak, or in search of the real laws of nature, and he had a very intelligent method of, and he also talked about this, that he was a professional mathematician, but he was relatively weak in mathematics with respect to Cartan or others, and but I mean, one key element of scientific discoveries is intuition, And I think this is one important thing. And another important thing about Einstein's methodology is, let's think about the big questions. Let's think about the unexplained numbers. That's a very that's a big topic in my book. Yeah, let's talk about unsolved problems, about these unexplained numbers in physics, and that's what Einstein also was very interested in his later years, and he explicitly said that I can't imagine there is a constant of nature popping up, and it's just the number 137 because it's 137 because it's the mood of the creator. I don't believe that. That's what Einstein words, and I totally agree. And this is in sharp contrast, to the modern approach of doing physics. So I think not only we have to remember the content of Einstein, we also have to look at his methodology, and this is why I appreciate him.
Oh no, absolutely. I think one of the things is we have one of our scientists in our organization, the CMPS. He's a retired NASA engineer. He
Mm-hmm.
worked with lasers, and he's the one who said, "Look, when we look at starlight, it doesn't bend when it's outside the corona." That's what he was saying. That's he was talking about general relativity. But what's super interesting, a side note to him, he is super fluent in German. He's an American, but he is super fluent. When he talks, he almost no accent. And he said when he reads the original works of Einstein, it's a totally different read from when you read it, what people translate it to, or what you read people who interpret what he says. It's you see a lot more doubt. You see a person, a person more, he says, exploring than you do a person coming down from the mountain with,
Mm-hmm.
the holy list of laws of the universe. So
Yeah, yeah. There's definitely a kind of humbleness in his writings, which I also like very much, which I think every scientist should be aware of. Yeah, I think so. He's definitely right about this. It's very, there is a lot of sympathy in his writing, which I don't know might not get translated in an easy way. Yeah, I think so. Yeah.
yeah. Okay, let's go on to further on the book. I'm gonna skip ahead because there is a lot in the middle, but I'm gonna skip ahead to some of the maybe subjects that will people will sort of grasp on pretty easy. Chapter 10, it says Big Bang without expansion.
Hmm.
Einstein desired cosmos. Now, maybe if you can remember, if not, I can. But basically, you're saying that there's a Big Bang, but there is no expansion going on. Can you relate that? How did that get into this book?
Yeah, yeah. By the way, that's the most important chapter.
Oh, very
That's the
good.
culmination of all the arguments. I
Sure,
mean,
sure,
first
sure.
I'm trying to put all the different voices together, Schrödinger and Dirac, but chapter 10 is something that tries to give that unifying picture of all these ideas. And well, the consequences. I mean, it's just as I said, it's putting the pieces together, and that cosmos of where there's no expansion of matter. That's in the paper of Dickey in 1957.
Sure, sure.
And but it's well founded, and it perfectly fits with Dirac's and Einstein's and Schrödinger's ideas. And well, the picture is the following. I mean, the conventional picture is you look at distant galaxies, you realize there's a redshift, and well, we interpret it either as receding velocity in the earlier, and later it was the expansion of space itself. But in any case, some kind of motion. But the more intelligent, I would say, explanation is that something happens to the light. Okay, if it comes to us from that far distances, it's not exactly that what was called tired light. It's not precisely
Sure,
that.
sure, sure.
It's something that follows from first principles. I mean, try to explain it in a brief manner. Um, the presence of masses decelerates the speed of light. Okay, so once you have a more visible cosmos, not because the cosmos is expanding, but of course light is expanding, and you see more of the cosmos.
Sure,
Okay,
sure.
you have just this light bubble you're watching, this cosmic horizon. So you're seeing more and more masses. Okay, these more and more masses, of course, decrease the speed of light. So something is happening in the cosmos. The cosmos is evolving. It's becoming more visible. We look at larger distances. We see more masses, and as a consequence, the speed of light must decrease. Okay, so of course, if the speed of light is frequency times wavelength, something has to happen with the frequencies and the wavelength, and as a consequence, from looking at large distances, you see the light relatively redshifted. And that's what already Robert Dicke said, and I think it's beautiful because for the first time, it gives you a coherent picture why we have these so-called Hubble expansion, which is not an expansion. But I mean, the discovery of the cosmic redshift was a big surprise to everybody. Nobody did expect that, and so people are forgetting that's an unsolved question. Why the hell should the cosmos expand at all?
Sure,
I mean,
sure.
as a physicist, you want to answer the question, and this is not answered. People are working on excuses if they're doing cosmology, but there is no explanation from first principles. And this cosmology, based on the ideas of Einstein and Dicke, provides that kind of explanation. It's just the only way it works. I mean, because light, of course, has to expand. Yeah, you can stop light once you open your eyes. It's light. It's an inherent property. It spreads, but as a consequence, you see all the matter in a redshifted way. So people think that the cosmos also, the material cosmos, is expanding, but it's not. It's not a logical. It's not a logical assumption. Yeah.
Yeah, well, in our group, as you know, we have a lot of people who look at that. In fact, there was a fascinating paper in our 2018 conference by Ray Gallucci, who just took all the galaxies and looked where they were in the
Mm-hmm.
sky and said, okay, because he always tests things. He says, I'm not good at coming up with stuff, but if you
Mm-hmm.
give me something to test, I will test it. So he went up and looked at it, and he said, okay, the distribution of galaxies, there can be a couple of things. There can be expanding from a Big Bang. They could be all moving out, and you would see certain thing, or they could be sort of more steady state, more sort of around, or they could be even coming in. What are the those are or and he took a look at it, and at least from his conclusions where he was finding it, it looked more steady state. It didn't look like there was an expansion going. He says, I tried everything I could to find, but then again, as you know very much, is that the mainstream science, what I call big science now on our Science World
Mm-hmm.
website coming out, our magazine, is big science. Their goal is to not is to support what's going on. They don't go out of their way and say, "Oh, Gallucci, that's a good thing. Let us look at that." And then
Mm-hmm.
they avoid that. I mean, that's one
Mm-hmm.
of the problems, right? They
Yeah.
don't they
Yeah.
don't go after those things, which is exactly what a critical thinker does. And even Einstein, I think himself would have said, "Yeah." I mean, if he would have saw Gallucci's paper, he'd look at it and say, "What is this?" instead of today, and that's a frustrating part. I'm going to
Mm-hmm.
keep going here. I'm going to go to chapter 12 here, and it says,
Well, let me just
"Oh,
briefly comment
yeah,
this.
absolutely,
Of course, I mean you have a lot of observations which contradict conventional cosmology, and you have lots of interesting observations which are really incompatible with the standard model. But I mean, this is sociology of science. You always are building up models in a more complicated way. We're in the midst of epicycles. I mean, dark matter, dark energy, or whatever they will invent for the next anomalies in the universe. That's just a modern form of the epicycles. And of course, people do not just discard the model they worked for a decade or two. And then if you go back and take a fresh look, and it scares people, no? That's
yeah,
understandable,
sure,
but
sure."
that's why we have to look at science from a large time scale, yeah.
Yeah, absolutely, absolutely. No, I agree, and I think it's quite one of the biggest things when I talk with people who've worked outside the mainstream. I've met so many amazing people, from PhDs in physics to just engineers and scientists who've been thinking a lot about this. And the older they have, I say, what is keeps us from moving forward? And they said, putting food on the table.
Hmm.
And I said, what's, he says, yeah, well, you got to make a living. Now you're going to tell me that I've looked for black holes, super black holes all my life, and now all of a sudden what we can call a black hole really doesn't exist. There's something there, but we're going to have to say it's not a black hole. What am I going to do? Learn how to do web programming and build websites? I mean, it is of human nature. But I will go
Yeah,
forward.
but that's the risk as a scientist. You have to take this risk. I mean, I
Yep.
also have the risk that all my theories are nonsense and will turn out wrong. Okay, but that's once you make that decision for your life, you should accept that kind of risk. But it's not easy. It's certainly not easy.
Yeah, for sure, for sure. So chapter 12 talks about forgotten but not hidden. It says Einstein's idea is visible long since. It is dark energy. And you mentioned a little bit about that. And that's also something we hear a lot about, is dark energy, dark matter. People in our group, my father and other people, have done analysis that the gravitational pull of a galaxy is not uniform. And when it's not uniform, therefore the star speed can be explained by Newton itself. But there's something similar that when I was reading through the book about that. What is this? What are you talking about in Einstein's Lost Key about in particular? The idea is visible long since, meaning before, and how that relates to dark energy.
Mm-hmm. Mm-hmm. Yeah, I mean, well, people say something. Okay, you set up a bold new theory. Give me the evidence, but it's not exactly like that, because I mean, I say the evidence is already there because you have different models of interpretation, and if you look closely, you find much more evidence for this variable speed of light model. Let me explain. And you have to take a little bit the historic point of view looking at dark energy. I mean, we have Newton's law of gravitation, which is well tested for the solar system, okay, 10 to the 12 meters. But we are extrapolating this law in an incredible manner over, I don't know, 14 orders of magnitude. That's kind of crazy. But but everybody thought, okay, we look at this expansion of the universe. And now a very natural question, if you start from the hypothesis of an expanding universe, a natural question is, well, will it expand forever, or will just we know that gravity slows down the expansion, or will that gravity eventually stop the expansion and we have a collapse again? You know, that's what people discussed in the 1960s, 1970s, an open and a closed universe. And again, interestingly, the universe was just in between without good reason. Okay? The so-called flat universe. That's already something very weird, very strange, something that should point you that there is something wrong in your model. And then the question was not settled, but everybody was, of course, convinced that gravitation should slow the expansion should decelerate the expansion of the universe. So when people in the 1990s had these telescopes, new telescopes, these programs of observing distant supernova, the big surprise was, oh, there is no deceleration at all if you look at distant galaxies. At the contrary, and they said, oh, it's not decelerated, it's even accelerated. Here we are, Nobel Prize accelerated universe explained by dark energy. Mm-hmm. But you know, if you take a sober look, it's kind of ridiculous. You expect that there is a deceleration, you don't see it, and then you postulate an acceleration that exactly compensates for this non-visible deceleration. and the much more, how should I say? I mean, the much more natural view is that there is no deceleration and no acceleration at all. Okay, and that would be the solution of these Dirac and Dicke-Einstein theory. And by the way, there is new data. There's after the book was published in 2017, there was a paper that saying that the evidence from distant supernovae for dark energy was marginal. You know,
Mhm.
and I mean, if you look now, if you take that 2017 evidence, nobody would get convinced that you need dark energy. Yeah? But back then it seemed that you need that acceleration, and so everybody put that strange dark energy into the cosmological model. Everybody works on it, and it's established, so to speak, for 20 years. But well, you should take a sober look and say, well, this doesn't make sense. There
Well,
is no deceleration, there's no acceleration, there's no movement at all. That's the solution. It's very simple.
it's funny because two of the things that you're talking about, the speed of light, and also dark energy, it's something that it seems that the mainstream wants to link that to Einstein. But if you go back and look at Einstein, you like you did, which is one of the things that critical thinkers do, and look at the other people, you get a different picture. So it's this dichotomy of you have the mainstream who worships to actually a fault a
Yeah.
person who was a critical thinker, but not the only one. And they then take it. It's sort of like the Monty Python film where the guy says, "Look, I'm just a regular guy." They start worshiping him, and they're interpreting all this stuff. And the guy says, I didn't say that. That's not what I'm talking about." But they seem to they don't care.
Yeah.
This seems to be
No, they
a
don't care.
theme of your book, of the Einstein keys.
Mm. Yeah, it's kind of strange. Yeah, what they're convinced that they speak in the name of Einstein, but they don't really know. It's very, very strange. Yeah, even if I might add that if you read the biographies, the well-known biography by Abraham Pais, I mean, I have it on my Kindle and say, okay, let's search variable speed of light, and it just doesn't show up. It I don't know. It shows up maybe once like in a footnote, because as it was, and Pice talks about this 1911 paper as if it was something very strange, irrelevant, insignificant. And I mean, he just discards everything which does not fit in the modern picture, and he just focuses on these papers which are worshipped today. But that's a completely distorted picture of the research Einstein actually did. Yeah.
Yeah, I think that's sort of a major, how do you say, a major theme that runs among people who are critical thinkers who sit back and take a look at things. Because when you
Hmm.
go back and you study and you look at the origins, like if you look at the origin of the neutrino, for example, like Dr. Karazani did, the person who got me involved in this whole idea that things could be not as they seem. He went back and looked at the time when they were Pauli was saying, look, if you guys are going to apply special relativity, you're going to apply it to decay or radioactivity, and if you do that, even though we're measuring exactly what we should, there's got to be magical stuff there. And then all of a sudden the neutrino comes out. Then when you ask neutrino people 50 years later, what's the origin of the neutrino, and says, well, I'd say to them, well, from what Karazani found out, it was sort of a way to save the application of a kinetic energy equation wrongly, which to a decay case, and they go, "Oh no, that has nothing to do with." I said, "What do you mean? That's a history. You can't find it in the history books or the
Hmm.
physics books." And the answer you get from these people is, "Well, that's old. We didn't understand it." And if you think about it, that's just absolutely. It's almost like throwing out it's like 50 years from now, sir, what you're saying, people are going to say the same thing. Anything you've done,
Yeah.
they're going to say it's old and throw it out. I said, we have to go back and look. And I think that was one of the things that I really enjoyed about your book. Even if a person's not into all the details or what even the implications are, the history of this stuff is fascinating because you get a
Of course,
wholly
of course.
different picture of who Einstein was, the people who were thinking, and it's almost like that's why I think I'm showing the audience here the book with my markers in Einstein's Lost Key. It's almost like a
Mhm.
treasure hunter, right? I mean, that's what I feel that you feel. Does that sort of sum up what this book seems partly to you?
Mhm, mhm, mhm. Yeah, yeah. Well, regarding the neutrino and Pauli stuff, I once had a talk, a fictitious letter by Wolfgang Pauli to I read that to a
Oh
neutrino
yeah,
conference.
I remember
But
that. I saw that. I
aside.
loved
That's an
that.
aside. But for general point, um, well, it's I think this kind of distortion of this wrong kind of thinking, this focusing too much on the present and discarding the history. I think that's kind of hardwired into our human brains, you know.
Sure.
I read a book by Daniel Kahneman, who won the Nobel Prize for Medicine, I think, and he talks about the concept of um, the illusion of focusing your mind on the present,
Sure.
of which is before your eyes, you know. And this brings us often. I mean, everybody has this problem if you look at your life. But this brings you to focus your attention too much on the present, too much on what is going on in research right now, and to discard the history. And if you want to have a really unbiased, sober look at science, I think everybody should look much more at the history and the development. And but that's that's absolutely not what's the current fashion of, of physics is. On the
Yeah.
contrary, I
Yeah.
think what physicists are sometimes are taught at the universities, it's a kind of arrogance
Yeah.
that oh, we are so smart, we know smarter than 50 years ago, since the beginning of this and that we have learned this and that we know, you
Hmm.
know. That's not true. If you
Yeah.
look at
Yeah.
the laws of nature, you find so many weird, strange, unexplained things that makes you humble.
Sure.
And
Sure.
I think it's the exactly wrong attitude physicists
Yeah.
sometimes
Yeah.
have to take.
Yeah.
Yeah.
Well, listen, thank you so much. I appreciate you coming by, and I promise this for a long time, and I promise also to do the Einstein's Lost Key. It's really worth it, everybody who's subscribed to my channel. Get the books. It's not only this book, but his book, Bankrupting Physics, as well. And the Higgs Fake is a definite read for everybody. Put it on my all-time list of books you must read because this is one of those books that will open your eyes with a sledgehammer about what's going on. And we're going to talk more with him. So I'm going to have stay tuned. Hopefully you'll pay attention here, stay here, and I'm going to have another interview with him coming along really shortly. But I want to thank you so much, Alexander, for taking your time there in Germany. I really appreciate it. You got a lot of admirers here, so thanks so much.
Okay. Thank you, David. It was a pleasure to talk to you.
All right.
Thanks.
All right, everybody, remember what I say. This is David D. Hilster. I am your science therapist, trying to get you to science woke, and people like this, certainly in those books like Alexander writes, Dr. Unserker, you got to read. So, till next time, ciao for now.